5d, and so on, 5f. There is 6s, 6p, 6d, and so on, 7s, 7p, 7d, and so on. So now, once we need to fill these orbitals, as you know, or we need to explain this, that the maximum of electrons in the s, how many? 2. And in every s, 2 electrons. And every p can take maximum of 6 electrons. And every d orbital can take up to 10 electrons. And the f orbital can take maximum of 14 electrons. So now, how can we arrange, put them in order, depend on the practical and analytical chemistry? So it's been found that the first lowest energy level, so this is the energy level, we come to from lower one to the upper one. This is the increase in energy. And then once we want to configure the electronic configuration, so first we go with starting with 1s2, and then we go to 2s2, and after 2s2 will come 2p6, and then 3s2. And then you go to 3p6 and see 4s2. So 3p6, 3s2, and then 4s2. 4s2, after that will come 3d10. 4p6, 5s2. And then we come back to fill 4d10, 5p6, 6s2. And then we come to 4f14, 5d, 6s, 6p, 7s. And then we come back to 5f and so on the rest. So these are the order of how to put the electron configuration. So if we want to do electron configuration for to arrange these, so we have to say they start with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, of course I am following here, let's go here, it's better, 4s2, and then 3d10, 4p6, 5s2, 4d10, 5p6. Okay, so that's how we follow the order, and you can continue for 5p6 and then 6s2 and so on for the rest. So this is the, as we see here, it's very important to see that 4s2 always comes before 3d10. It's overlapping. They call it overlap of this because 4s2 is lower in energy than 3d10. 3d10 is higher in energy than 4s2, and you can see the rest as well. So we have to notice this. Now, if we want to organize or arrange the electron configuration for boron, like if I want to go with the boron 5, can you see that? Yeah. So boron 5, we have to follow the order. We say we have to draw this, you have to memorize it, and then you go with 1s2. This is it depends on the of-vow principle. So we have 5 electrons, we put 2 in 1s2, and we have 2s2, and this is number of electrons, 2 and 2, 4. 1 is remaining, we put it in where 2p1. So here, as you see, this is the first main shell. This is the second main shell. How can I say second? This 2, 2. This is the first principle of quantum number. So now if I want the 4 quantum number